Hello everybody, how's everybody doing? I hope you're doing fine. We have an exciting day today in physics. Sad day for mathematical physics, mathematical physics. Terrible day for quantum mechanics, for general relativity, but great day for physics. Okay, we're going to be talking about a couple subjects that a lot of people are interested in. Okay, they don't concern physics that much, but somehow the mathematicians managed to bring these things into physics, and so we have to deal with them, because they claim that physics can tell us something about it, and that is about free will and determinism. So here's a question for you. Do you think you have free will? I mean, do you think you can do anything you want, or do you think someone's pulling your strings from above, or that makes you walk in a certain direction, makes you do certain things? You think you're being guided by some kind of invisible hand or something? The interesting thing about this question is that the mathematicians conclude that it's both. You have free will, and there's also determinism. You're being pulled by the puppeteer, okay? But you do have free will. You're a cartoon character in a cartoon. You're Bugs Bunny or whatever. And here's the script writer. He said, okay, Bugs Bunny should do this, should do that, then he should move this way, he should say this. And that's what he lays out, that's what he programs, that's what he draws and everything. He's got it all set up. And it turns out that the cartoon character, Bugs Bunny, says, hey, I'm not going to say what's up, Doc, anymore. And he goes off the screen or does something else that you did not program or put in there. Now that's scary. When the cartoon character has life of its own, it's dangerous. It means, probably you've been overdoing it on the booze or something. Imagine God, he programs everything. You got to do something according to how he already programmed it for the next gazillions of years. And it turns out that you don't follow the script. He's already laid it out. He said, look, I've got all the frames of the film for the rest of eternity. It's there. All you're doing is walking on footsteps, right? Because he knows the future. And it turns out that he doesn't know it because you decided not to walk those footsteps. You did something else, and Joey did something else, and his neighbor did something else. So everybody does something else than what God planned, which means that he did not know what was going to happen. And so this issue of the fight between determinism and free will, it's been around for at least 2,000 years, and probably even more. I think even the Greeks with their gods, they probably pondered that. Maybe even the Persians, Sumerians and so on, they probably dealt with these issues as well. It probably came to their mind, these issues. And here's a list of some of people who dealt with the issues. It starts with the Bible. It says, for whom he did foreknow, he also did predestinate. Moreover, whom he did predestinate, them he also called. And so for those people who believe literally in the word of the Bible, God apparently predestinates every person, meaning he already knows what's going to happen in the future. And that is consistent with being all-knowing. Okay, so all that so far is consistent. You've got all these prophets or writers or theologians or whatever throughout history, and I'm only mentioning 6 here, probably some of the most prominent in the Western world. But there's been, this has been a subject that's been debated for centuries, over and over and over again. There's been fights over this issue. There's been excommunications. There's been burning at the stake. There's been a whole lot of stuff over this issue. So it's been an issue that's been around for hundreds and hundreds of years. Do we have an answer today to this issue, this simple issue? And it turns out that the mathematicians do have an answer, and that is they ended up with all, like all the others, they ended up with both. They were able to figure out a way to cover all the bases. You have free will, and your future is already predestined. We know exactly what's going to happen. God knows, at least, or someone knows. The universe already exists out there, and all you're doing is walking into footsteps. So it's both. And you try to figure out if you can reconcile those two notions. Okay? Yeah, it's one of the things that debunks traditional religions. That's essentially what it comes down to. Okay, so we start with this gentleman. His name is Pierre Laplace, French guy, days of Napoleon. And he suggested that if we knew, he was a physicist, mathematician, etc., right? And he calculated, he said, if we knew how the position of every particle, the location and where it's moving and what it's doing, etc., we could predict the future because it would be a mechanistic universe. We would know where that particle is going to be, where that particle is going to go next. So he says, we may regard the present state of the universe as the effect of its past and the cause of its future. An intellect, which at a certain moment would know all forces that set nature in motion. He's talking about God, even though he didn't believe in God. He didn't he was an atheist, okay? And all positions of all items of which nature is composed, if this intellect, okay, were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom. For such an intellect, nothing would be uncertain, and the future, just like the past, would be present before its eyes. He described the blocked universe, essentially. He says, look, if there is such a thing as knowing all the positions and locations and movements of every little particle in the universe, if there is such a computer, such a mind, such a God, all-knowing God, right? Then the future could be predicted because we would know exactly how that particle is going to move next, and the other one, all of them. And so we could predict exactly what's going to happen in the future. There would be no uncertainty. Okay? And so he's saying that, and remember, he's a guy who was an atheist. He didn't believe that there was a God out there. Napoleon asked him once, what about God? And he answered, I have no need of that hypothesis. Okay, it turns out that this is what 200 years later we have Mr. Al-Khalili say exactly. This individual, he vouches for the blocked universe. Okay, and he says, if we could know the position and state of motion of all bits, the building blocks of the universe, we know all the forces between all the particles, the atoms and the particles that make up all the atoms. If we knew what everything was doing and where everything was in the universe at a given moment in time, then this view of time that we inherited from Newton, okay, clockwork universe, right, tells us that in principle we should be able to compute how the future would evolve. That's what I mean by deterministic universe, the Newtonian clockwork universe. Okay, so it's a mechanistic universe that he's describing here. He says, if we knew all this, well, then it's just like Laplace said. All you do is just compute what every particle is going to be doing for the next, series of, for the next time, amount of time, and then you can predict the future perfectly. And if you can predict the future, the question is, are you just predicting, or does that future already exist out there, and are you just following the footsteps of a pre-programmed script? Okay, that's going to be the issue. He says, since our bodies, our brains are made of atoms, particles, physical entities subject to the same laws of nature as anything else, then in principle, knowing the future means knowing what our actions will be in the future. So determinism tends to suggest that the future is preordained, that we have no free will. Okay? Now, one question a lot of people ask is whether living entities, which especially animals. You know, they have the ability to take decisions and go left instead of right at the last moment, whether that's part of this mechanistic universe. Okay, and that's what keeps people from arriving at a solution, sometimes personal, belief or whatever, of whether this is true or not. They say, well, if you talk about asteroids going around, the sun, and that sounds mechanical. But humans at least, if not other animals as well, they don't function exactly so mechanically. They kind of take decisions at the last moment, go this way instead of that way, and the question is whether that's predictable and whether that can fit within these descriptions. Okay, so that's going to be in the background for those of you who believe that it is possible to have determinism and free will at the same time. Okay, Al-Khalili continues, and he says the following. He says, in Newtonian mechanics, we have the idea that fixing the initial conditions, say, in a game of pool, we will be able to compute how the future will evolve, okay? We can never know in infinite accuracy exactly where every ball is so that we can crank the handle. The equations to work out what's happening in the future, because the slightest change in temperature or humidity or a grain of dust somewhere would eventually magnify and alter the future. Okay, so any little variable there can change the whole thing. Okay, this is called the butterfly effect, and it's part of something they call chaos theory, but it doesn't rule out this notion of determinism that in principle, were we able to know, then the future is fixed. And this is what he's referring to. He's referring to something like this, where known as a butterfly effect, where if you have this little pendulum, and it depends on its starting condition there, right? That's what it's going to draw, because you can calculate each one of its motions after that. If you start at a different point, and if you have some other variables come in there and mess up your calculations, then it won't have this smooth or these curves. It would have a different type of motion and a different type of drawing and different type of pattern. That's what you would come up with. Okay. Okay. So Al-Khalili says, well, Newton was doing fine, but then Einstein comes around. He just reinforces Newton. He takes it one step further. He said the Newtonian universe was compounded by the turn of the 20th century when Einstein developed his theories of relativity. Relativity leads to this notion of what's called the block universe. Okay? And so now we're going into something a little dangerous, because not only does Newton and Laplace say, look, if we knew all these particles, where they're moving, where they're at, and how they're moving, what direction, all this kind of information, we could predict the universe. Now Einstein says, hey, don't worry about calculating all that. The future already exists. There is this block universe, and the future has already happened. The future is the past. For whom? Maybe for God, I don't know. But this is the notion that they have in general relativity, that you have this this big loaf of bread, as Brian Greene illustrated. That was the analogy he used. And he says, if any slice, very thin slice across that loaf of bread, that's one bit of time. You make it as thick as you want. You want to make it a 1 second, a microsecond, a nanosecond. Make it as thin as you want. Okay? But he says, the universe is made of all these slices of time. Okay? This is the notion they have in the whole. All these slices form this big bread called the block universe. Okay, that's where they're headed with this idea. Okay, and here's what he's referring to. That's the block universe. I always think of it as a little glass that just fell over and all the beer came out. Okay. God's probably astonished to see that. He's probably freaking out. Okay. And here we have the block universe that he's referring to, something more or less like this. He describes it. He says the block universe is a 3D block meant to signify the whole universe, the whole of space. But space is just this flat surface. See there, it's just a two-dimensional flat surface, space, on the picture on the right. Okay, time, on the other hand, has this linear direction toward from left to right, but space is only 2D. Okay, it's flat. And he says, we've thrown away the third dimension because then I can use it as a time axis. No kidding. He can't picture this thing. He can't put 3 dimensions of space and 1 of time because they would not be perpendicular to each other as required by the notion of dimension. And so he artificially, by brute force, he just chops one of the dimensions out. And he said, I'm just going to leave 2 dimensions. And this, he says, well, he'll say here, imagining cross-section through this universe, which is our now. Behind now is the past, in front of us is the future, and a point on the now is our here and now. Okay, and he says this is a very useful way of solving problems in physics. Well, I don't know about physics. Looks like he's talking about mathematics, because this has nothing to do with physics, and the fact that he got rid of 1 dimension shows that he's not going to be dealing with 3-dimensional entities, which is what we have in our universe. I don't know of any 2-dimensional planes floating around, but this is what they're going to do because they can't imagine their 3rd dimension in this scheme of things, and so they have to get rid of 1 of the dimensions. Okay, so that's how they do it. They're going to get rid of 1 of the dimensions. Does that make sense to you? Instead of a cube, they're going to be dealing with squares. Instead of a sphere, they're going to be dealing with circles, etc., etc. Okay, let's see where they want to take us with this. And so he says the following. He says, what it suggests is something even more dramatic, even more bleak than Newton's clockwork universe. Ooh. In Newton's universe, the future is fixed and preordained. Fate, as it were, but it hasn't happened yet, even if we could predict what would unfold. Listen what he's saying. He's saying it hasn't happened yet. But that's not what the block universe tells us. The block universe tells us that it has happened, and we're looking at the past from a farther past. You're farther past from the past. So he's saying it hasn't happened yet. Okay, it's getting scary, but it's going to get scarier, I think. Okay, let's find out where this takes us. In Einstein's universe, the future is just as real as the past. Well, if it has, we have a problem. It hasn't happened, but it's real, he says. He's got a contradiction right there and then. He says, it hasn't happened, but it's real. What does he mean by real? Well, they never define the word real. They never define what exist means, and so they can get away with murder. Okay? Says the future is just as real as the past. Everything is frozen and static, so it's already there. It's a picture. You're moving into a picture. If you saw, maybe I should have put that in there. If you saw Mary Poppins, you see how Bert and Mary Poppins, they jump into a picture, and that's more or less what these people are saying. That you can jump into a picture, and you become part of that picture and whatever is going on in that picture. This is the view that God has. Yeah. So we're talking here about God. Yeah. They have to introduce the word God in there. He doesn't like the word God. He claims to be an atheist or whatever. But yeah, they have to introduce God here because we're going to go into what we know and how we know it. And that's God. You know, if God knows everything, God knows the future, we become God, so to speak. You know, suddenly we can predict the future. We talk about knowing the future, right? That's what these people are talking about. So they're trying to become like gods, or they think they are gods. I don't know. Does this really mean that the future is there? Well, he just said it's real. It's as real as the past, so it better be there, right? That it's happening? No, we're saying that it happened, not that it's happening. It's already finished. It's done. That's what he said. It's real. And he said it's static, frozen, static, real. What is he talking about? He's saying it's there. And now he's saying that it's happening, that our present moment is no more special than any moment in the past, any moment in the future. This has nothing to do with whether a moment is special or not special. Now he's drifted off into a tangent. He doesn't have to introduce this notion of special, whether we're special here in the present or in the future. The issue here is that he's saying that, does this really mean the future is there? And it better be there, because he says it's real and it's frozen and it's static. And he's talking about a block universe. What is he talking about? He's talking about that time already has completed. We're already, in other words, the big crunch has already happened. Big Bang to Big Crunch, that's what, gazillion years? Gazillion years are over. The whole time block is finished. It's all done with. It's there. It's a picture. It's static. All we're doing is walking through there. And if you can go to the future, well, you should find something as real as in the past. Something as static, that you land somewhere, right? Somewhere and somewhen. It's not really necessary to view all the future as fixed in this deterministic way. Yeah, because it kind of destroys your free will. And so you got to leave some hope for people saying, oh, you mean my future is already determined, why should I worry? You know, if I robbed the bank, I can tell the judge, it wasn't my fault. It's God that programmed me that way. The judge said, yeah, he programmed me to put you in prison. It does suggest that the future is predetermined, but it's not the whole story. Okay, so he's going to make a little loophole here. He's going to go on a tangent to try to save his argument. Okay, that's where he's going, and that's where all relativists typically go, right? What is he going to do? Well, he's going to go into the twin paradox. He's going to use that as proof, as evidence, saying that, oh, we've proven the twin paradox, and now I'm going to synthesize it for you so that you can see why we have reason to believe all this. And he talks about Alice and Bob. Alice goes on a trip. She can go to the future. She can go anywhere. In fact, we had her last week, and she went on a trip, faraway trip, came back. She went close to the speed of light. When she comes back, she's got she's got a different age than her twin brother, Bob, who stayed on Earth. He aged maybe 50 years, and she aged only 1 year. And this is a calculation that I've shown last week that mathematicians do, and they say this proves that it's true, and then they prove this supposedly with an experiment, right, that it's true, that time does dilate when you're traveling at close to the speed of light. And one of the issues there with this time dilation that you have to keep in mind is what I keep saying, and here Al-Khalili also was asked that question, and that's, how many times did the Earth go around the sun? And the Earth goes around the sun once a year, 365 days. And so when the question is, how many times did the Earth go around the sun when Alice went out and came back? And Al-Khalili, didn't answer that question. He answered a question that he wasn't supposed to answer. He said, well, from Alice's point of view, the Earth is traveling at a different speed. Well, we don't care about that. We care when Alice comes back and meets her brother again. They're both on Earth back again. How many times has the Earth gone around the sun? Has it gone 50 times or 1 time? That's an objective criterion. When she's back, we got to look at the calendar to say, how many times did the Earth go around the sun? Well, it went 50 times. And here's the calendar. You left in the year 2000, came back in the year 2050. 50 times have gone around the sun. That's 50 orbits. And she might say, well, my atomic clock says something different. Well, I don't care what your stupid atomic clock says. The question is, how many times did the Earth go around the sun? And that's objective. And we don't care what your atomic clock said. We don't care how fast you went out there to the black hole and around and back. We don't care about any of that. When you come back and meet your brother, if you say that he's 50 years older than you, well, you got a problem, because you got to justify that. You got to say, well, how many years does he have? Well, he has 50 years. You better have 50 years as well, because that's how many times the Earth went around the sun. And if you only go to Mars and back, again, traveling at the speed of light around Mars and then come back, we got the same situation. You can't, so you don't have to use a faraway black hole. You can use it to Mars or something close by here in the solar system. Come back. Well, hopefully, I don't care how many times you went around Mars. Mars travels at the same speed as, or more or less, slower, half the speed that Earth goes around the sun. I think it's 656 Earth days or something along that line to go around the sun. So the Earth goes maybe 2 times while Mars goes once. And so she can go around Mars as fast as she wants, close to the speed of light, then come back to Earth. Hopefully, the number of times Mars went around the sun matches more or less, the 2-to-1 ratio between the Earth and Mars. Okay, so it doesn't matter how fast she goes around Mars. Okay. Anyways, he introduces the twin paradox, and he goes in there and he says the following. He says, time travel into the future is possible. He's going to use this Alice and Bob analogy, twin paradox, they're twins. But it doesn't necessarily mean that the future is out there waiting for Alice. Then what is waiting for her? What is she landing on when she lands on Earth? Or, where does she land? Is she going to land in Mars? The same thing. Earth and Mars travel around the solar system. There had better be a relationship there between Mars and the Earth. Okay, can't be that she suffered so much difference in her time than her brother on Earth. Okay, that the future has already unfolded and she's getting to that future. All that's happening here is that she's moving out of Bob and Earth time frame and fast forwarding into the future. She's getting to the future before everyone else. He doesn't say she's getting to Earth 50 years in the future. He doesn't say she's getting to 50 years in Mars in the future. He's saying she's getting to the future. Future is a concept. You don't get to the future. Tell me where she got physically. Where did she land her feet? In a jungle, in a desert? I need to find out where she landed. What does this future thingy, what is it? Okay, that's what he's got to answer. He doesn't answer that. He goes to concepts. Says she went to the future. Oh, where is it? Please draw it for me. I want to know what the future looks like. Okay? And she's getting to the future before everyone else. Less time has gone by for her. Yeah, when I sleep, I have dreams, or maybe if I drink too much booze, then time also dilates for me. What does that mean? It's personal opinion. Just look at the calendar and you'll sober up again. Okay, her time really has slowed down. She really has time traveled into the future. Again, into the future. He doesn't say time traveled to Mars or to the Earth in 2,000 years further on. When you see Marty and Back to the Future, he always lands somewhere, okay? And that's what I want to see these guys talk about, the mathematician. Where do you land? Give me a specific, place. Are you landing on Earth? Are you landing in Africa on Earth? Are you landing in the year 2050 for Africa on Earth? Where are you landing? This is not just some theory someone has come up with. We know this happened. There's the authority. He doesn't explain it, but we know it. We proved it. You better believe it. All you can do is memorize it like he did, okay? Because otherwise he wouldn't get his degree, okay? It's been proving time and time again. Yeah. This is how they do it. They just tell you it is so. Okay, and but the way we do it in science, we look at how many years went by, and a year is just one revolution of the Earth around the sun. And hopefully when Alice comes back, she just looks at the calendar and can tell very easily, without her atomic clock, how many times the Earth went around the sun. So this is a very easy issue to solve. Okay, it shouldn't take any mathematician to resolve this. Just count, if you're a elementary school kid, you can count how many times went around the sun. Just look at the calendar. You'll know if it's went 2, 3, 4, 5 years. You don't need to be a rocket scientist for this. Okay, so here we have what they're referring to. This is the block universe, and you have all these slices of time. Okay, you can think of those as thin as you want. Okay, so let's do a little time travel. Let's say you wanted to go back to the past. I've chosen a date. I'm going to choose the year 800, the days of Charlemagne, for those of you who heard about him, read history, okay? And Charlemagne lived around 800 AD, okay? Almost 1,200 years ago or so. we're going to go back in time, okay? We're going to go to that slice that is 800, in the year 800, okay? Now, when you go back, if what these people are saying is it's true that you can go back in time, let's assume that for a second, well, then what would you see? Well, you would see Charlemagne, you would shake his hand, you would land in France or, in Aachen in Germany, one of those places. You would end somewhere in Central Europe, and maybe you end up in a battle, or somewhere, or maybe in his palace. So you would see the people in those days. What would that mean? Well, it would mean that you would have that situation I explained the other day, okay, where you went back. In this here example, I have the year 0, but it's the same concept. If you went back to the year 0 or the year 800, anytime in the past, the Earth, the entire solar system would be somewhere in the universe where it's not today. So every galaxy, every star in the universe moved to a different location. And what these people are saying, that when you go back in time, you go to a time where the solar system is at a certain location, not only with respect to today, but with respect to every other star and planet and asteroid and atom that was, there 2,000 years ago. Is this possible? Can you move to the Earth to see Charlemagne or to see Jesus Christ, for example, in this case, 2,000 years ago, where all the stars and galaxy and everything moved backwards to that file, to that file in your file cabinet, to God's file or God's file in his computer? Is this possible? Does this make sense that the entire universe moved backward, or that there is such a file that you just go in there and land on? A three-dimensional file that's got time on one of its axes that we can't imagine? Yeah, so this is the problem. So what is the problem when going forward? Well, when you go forward, here you go to the year 2100. You're in the year 2020, and now you're going to move to the year 2100. Where do you land? What are you going to see? Are you going to see your great-grandkids? Is this what... are you going to land in whatever country you live in, and you're going to see your great-grandsons or whatever? Is there something there? But he says it hasn't happened yet. And if it hasn't happened yet, where are you going to land? I mean, what are we talking about here? Is there a file or not? That's the only issue. Is there a file in God's computer that you can land on, that you can say, okay, this is the year 2100? Is there such a file? Does God move every little atom in the universe to the location where it will be in the year 2100? And if so, it's already happened. That means that we know, if we know everything that's going to happen from the year 2020 to the year 2100, then that means that you have no free will, because all those files already exist. And all you're doing is just walking through the motions. You're walking through the footsteps that are already there. So they haven't solved the problem. And this is the problem that really destroys traditional religion, the notion of an omniscient God, because you can't reconcile an omniscient God that knows everything, knows the future, knows what you're going to be doing, knows whether you've been predestined to go to heaven or to hell. You cannot have that on the one hand and free will on the other. You simply can't. And they go through all these, all these philosophical arguments trying to reconcile and cover all the, reconcile the two and cover all the bases. That's what they've been trying to do forever. And the mathematicians are no different. Quantum mechanics tries to reconcile general relativity on this issue, and whereas general relativity says your future is already predetermined because there's this block universe, all you can do is just walk the path that already exists, even though Al-Khalili then gives a qualifier, says it hasn't happened yet, which I don't know what that means. You got a tremendous contradiction there. But then we have quantum mechanics comes in there and say, we have uncertainty, indeterminacy. And so that saves the day. And that's where Al-Khalili goes next. He goes in there and he says, look, Fortunately, we have quantum mechanics. And determinism, the idea of the future being predetermined and preordained because of relativity, got a bit of a wake-up call in the 1920s, quantum mechanics. Whereas general relativity describes the whole universe, how gravity affects the nature of space and time itself, quantum mechanics is the theory of the very tiny, the theory of the subatomic world, which I don't know what has to do with you, who are a macro object going to the future. The fact that maybe there is some uncertainty, let's even concede that. There's uncertainty in the atoms in your body, that you can't know the position, the location, the momentum within for that particle within your body. What's that got to do with your body, your entire body, moving to the future on this block universe? But that's what they're going to say. There's uncertainty at the atomic level, so we saved indeterminacy. Otherwise, you wouldn't have free will. And he says, and it's much weirder than relativity. No kidding. It has to do with cats in boxes being dead and alive at the same time. Skier going through both sides of the tree at the same time. Is this something you're going to put your life on the line for? If the devil comes to you and says, look, do you believe in this or not? Your life is on the line. Which way you want to go? I mean, would you really believe that, that particle can be at two places at once, cat can be alive and dead at the same time, skier can go through both sides of the tree at the same time? That's what things down at the quantum level really do. And no one has a common sense way of explaining how that happens. Yeah, because you're doing it with particles. That's why. And you can't do the invisible world of Mother Nature with particles. They haven't discovered that in the last 2,000 plus years. That's the issue. We have to get rid of the particle hypothesis. You cannot simulate any of Mother Nature's invisible phenomena with particles. That's the problem. And yeah, if you try to do it with particles, it's unimaginable and you cannot put it on the screen for us. And you have to invent all this garbage, this nonsense that these people have invented, at least in the last 100 years. Okay, so what does he conclude? He says, quantum mechanics rescues us from this bleak determinism because down at the level of atomic, of atoms, it's subject to the laws of chance and probability. Again, what does an atom have to do with you moving to the future on the block universe? Okay, the fact that there's indeterminacy, uncertainty, assuming that's true, right? At the quantum level, what's that got to do with macro objects like you traveling? Statistically, if we have trillions and trillions of atoms, we can work out something called their half-life. Yeah, it's like the buffaloes. You have tons of buffaloes. Each buffalo has free will, but they all, go with a herd and they all fall from the cliff. And you can say, well, that's predictable. Yeah, maybe, one buffalo might go to the left and decide not to fall from the cliff. I don't know. Maybe they all fall from the cliff because they just follow along, like Al-Khalili follows, his predecessors. Buffalo going down the precipice. It says, how long does it take before the half atoms are going to spit out alpha particles and decay? Talking about uranium, spontaneously pushing out particles. But you look at one individual atom and you can't tell. Yeah, individual atoms, they might have a problem analyzing that. That's not an issue. The issue is, what does that have to do with a macro object like you going to the future? Because nature herself hasn't decided yet when this is going to happen. And that's the argument he introduces to say, fortunately we do have free will, because at the quantum level, atoms are unpredictable. We cannot tell you what their next location is, what their next position is, especially of the electron, right, around the atom. And because of that, that saves indeterminacy, which is a synonym essentially of free will. And they say, fortunately, we have free will, and we also have determinism, because you got to study general relativity for that. And right now we're doing quantum mechanics, so don't worry about that. So we have both, okay? And so he concludes, that's his closing argument here. And he says, quantum mechanics gives us back indeterminism. So our future is not decided. Nature hasn't decided what's going to happen next. That means the future is open. It means we've rescued free will. We are responsible for our actions. Okay, so sorry guys, if you thought that you were going to rob the bank and tell the judge that, hey, quantum mechanics says that I have free will, but, general relativity says, it was all preordained that I would rob the bank, and again, the judge says, yeah, and I was preordained to send you to prison. So do we have free will? Or is everything, are you a puppet? Are you a little cartoon character in a pre-scripted movie, video, or cartoon strip? Both. You have to do what the scriptwriter told you to do if you're Bugs Bunny, but Bugs Bunny can jump out of his script and do whatever he wants also, because that's allowed for by the laws of quantum mechanics. How's that for an analysis? Okay, I hope you can sleep well tonight. Okay, folks, let's get to the fan mail. I had quite a few. Again, I don't know if I'm going to cover all of it. Okay, so let's go with the first one here. Fellow says, mustn't a person believe the theory in their mind before they propose it? Is belief different than consideration? What is belief a synonym of, theory or opinion? Okay, so let's put belief in the proper context. Again, belief, we say that belief is 100%, 150% religion. Religion, the definition of religion is belief. Okay, that's what it is. And here we have it. Just a summary here. Whether you believe in a theory or not is irrelevant in science, because science doesn't deal with belief. Science is objective, rational explanations, that's the definition. And in physics, we explain what? Mechanisms that you can illustrate. You should be able to make a movie of your mechanism and keep your mouth shut. People should be able to understand just by watching the movie. Of course, if you can explain it in words, that's fine also, but preferably it's better to see a movie of the mechanism. Theory is explanation. Those two words are total synonyms. What theory is not is description. Okay, so mathematics can only describe, therefore mathematics has no possibility of ever having a theory. There are no such things as mathematical theories, because theories are explanations and not descriptions. And religion is what this fellow said, it's belief, opinion, conversion. Okay, so if you have a belief, and we all do, okay, by the way, all you've told us is that you have a religion. Physics, we have to be objective. We show a mechanism on the screen, people watch it, maybe you explain a little bit, some points that were not clear, and people understand the theory. Whether they believe or not, that's personal. That's their personal religion. Doesn't enter into science at all. We don't care what they believe. If they came out of the meeting, out of the conference believing, that's a personal, total personal issue. You go to church, you listen to the pastor or the priest. Do you believe? Well, if you believe, that's your personal opinion. If you don't believe, you came out of there, you say, well, I'm skeptical. Well, fine, that's your personal opinion. What's important is the objective part. The objective part, hopefully it's rational and objective. You see the mechanism, on the screen, you understand it, that's it. We're finished with science at that point. Whether you believe or not, separate issue totally. That has nothing to do at all with science. And that's the problem, because mathematical physics harps on belief. They say, I did an experiment, I've got evidence, here's the proof, here's the equation. All that's to persuade, to convince, to convert, to recruit. That's why mathematical physics, so-called physics, has a single purpose, and that's to persuade people. It's not there to give you an objective mechanism, because like Al-Khalili says here, we cannot even imagine it. Then if you cannot even imagine it, you don't have a physical interpretation, meaning you do not have an explanation, meaning you do not have a mechanism you can rationalize for us. And so at that point they go and they say, we've proven it. How did you prove it if you can't even understand it? If you cannot even illustrate it? What do you mean you've proven it? What is it that you proved? What they proved is something that they didn't see. They saw, they took the visible stuff. You know, you let go of the pen, you know, here it is. We let go of the pen, it falls to the floor. Okay, so you didn't see what brought it down to the floor, but you say, oh, but I verified that the pen falls to the floor. I did it 1,000,000 times, always fell to the floor. You can repeat the experiment on the other side of the universe, same thing, it falls to the floor. And this is the speed at which it fell, or the acceleration. That's only a description. So far you haven't told me anything about the mechanism. I need to know the mechanism. What caused the pen to fall to the floor? That's what you got to answer. And of course these people don't answer that question. They say that's beyond our understanding. So then the question is, what is science? What is physics? Is physics just a description? You say, yeah, it fell at such a rate and it always fell to the floor. Is that what science is? Yeah, it takes a dummy to say that. You need to think to figure out how that mechanism, how Mother Nature did that mechanism. Okay? And that's where mathematical physics is lacking. Okay? Another common question here, second one here. Fellow says, neither dimension or black holes exist. Yeah, neither one exists, okay? Because they're concepts, okay? Definition of exist from the Worldwide Dictionary. Have objective reality or being. Live or live, especially under adverse conditions. This is what we are going to communicate, like it or not. No, I don't wish to play with how we communicate. In other words, he doesn't want to play semantics. He wants to play with games. He just takes the definition from the dictionary and he's going to apply it, okay? If we both had different definitions of 50% of language, do you think we communicate? No, it doesn't matter how many definitions we have. The issue is you have to defend your definition. And you can't just go to the dictionary and say, this is the definition I found in the dictionary. Yeah, because the dictionary doesn't have scientific definitions. That's why. And so you can't use them consistently, meaning they're not rational. And so you have to rationalize the definition so that we can understand, for the purposes of physics, what you really mean. Okay? And so what we do in genuine physics, here, let me get it, if I can find it, is we define the word exist. Okay? You must define this word because it's important. And this guy says, okay, definition, he says it's reality or being, etc. Okay? And here we look at the word reality. What does reality mean? Well, the state of or quality of being real. So it's a synonym. And then it says something that exists independently of ideas concerning it. So it uses, so what is exist? Exist is reality. What is reality? It exists. What is real? Existing or occurring as fact. What is actual? Rather than imaginary, ideal, or fictitious, being an actual thing, having objective existence. And then you look at actual again, and existing in fact, in act or fact, real. Being the fact of existing existence. So all these are synonyms. So far we have no definitions. And so he says he took the definition out of the dictionary. We don't have a definition in the dictionary. There is no definition. All we have are synonyms. And of course, he doesn't want to define the word exist because it destroys his religion. That's the only reason he tries to skip a definition. Because if he were to define the word exist as we do, and let's do that for a second here. Here's the definition of exist, okay? If he uses this definition, his religion dies. And he doesn't like that, of course, so he's going to fight against it all for, to the last drop of blood. Physical presence, that's what it means. Object plus location. In order to exist for the purposes of physics, if you're going to talk sensibly, if you're going to talk scientifically, if you're going to talk rationally, then you need to define what exist means, and there it is, physical presence, an object that has location. That means it has to have location with respect to objects in the universe, all the atoms, everything that's out there. And what is an object? That which has shape, and location, the set of distances. So very simple. We do not need any of our senses to determine existence. We do not need to see, touch, hear, smell, or taste. That's not the proof of existence. You don't touch the chair and say, oh, now it exists because I could touch it. No, that's not the way it works. The way it works is you have to define exist, and then the chair exists by definition. So if God wants to exist, very simple. First, he's got to be an object. And that's not enough. Then he's got to have distance from his chest to mine, and then we can say that he exists by definition or pursuant to the definition. So it's very simple. You just define the word exist, and then we'll know whether God exists. Very simple. Okay, another comment. I think same fellow. He says the following. He says, know what the brachytochrome curve is. Okay. And I'll go over that in a second. Light is traveling in a curve as the fastest route. Yes, a curved wormhole would be faster than across the straight path. The shortest route is not the fastest route. What is this brachytochrome? Well, what it is imagine that you go through molasses. Well, you go a little slower than if you went through water, and you also go slower through water than you go through air. And you go through air probably a little slower than if you go through empty space, and so on. In other words, it depends on the medium. If you go through a thicker medium, a more viscous medium, then you're going to go slower. You try to go through iron, like maybe Superman did in one of his movies. Well, yeah, I guess you can move through iron. You're probably going to move slower than if you move through air, okay? Depends on, again, the density of the material, of the medium you're moving through. And here it is illustrated for you so you know what this brachytochrome is. Okay, here you have a triangle, and the question is whether the hypotenuse there is a shorter distance than the distance going from A and B. Okay, going, that part of the triangle, those sides. And you would say, well, no, obviously H is a shorter path, but that's not what they're talking about. They're saying if you have a more viscous medium like that red one there, then you're going to go slower throughout the hypotenuse, and you're going to go faster probably through A and B because you have a very shorter route. Like if that was gravity, both of them were just governed by gravity, you would roll slow along the hypotenuse, but you would go fast if you go straight down and then go sideways along the very fluid medium or very light medium. Okay, so yeah, so even though the path AB is longer than H, because of the media that you're traversing, right, and the amount of time in each one of those, you could get to the final point faster than the guy going through the hypotenuse. Okay, that's what this is all about. Okay, because we're talking about whether it's faster to go through a wormhole than through direct space. I mean, I see Andromeda over there. If I wanted to go to the Andromeda, you would think you would go in a straight line, and it takes 2.2 million years because that's, if you travel at the speed of light, right? Because that's how far Andromeda is from the Earth or from the solar system or from the Milky Way. On the other hand, they say you can take the shortcut and go through a wormhole that takes you real quickly over there to Andromeda, faster than the speed of light, not because you're traveling faster than the speed of light, like he says, but you're traveling through a less dense medium. Now, I can't think of a less dense medium than space. That's like, traveling through nothing. And these people are saying, no, you travel through time and it's less dense. That's what this guy is essentially saying. Okay, so what if you do it in reverse? What if you travel here, you see a different type of triangle. Here the hypotenuse is primarily along the fluid medium, okay? And so in this case, you would think that you reach that point where B and the H meet. You would reach faster through the hypotenuse than through the AB route because now, you're not being held back by the viscous medium. Right? You were held back in the first case, the one on the left, because most of your travel was through the viscous medium. But here, in this case, most of it is through the fluid medium, so here you would go faster. So what this fellow is saying is he's not talking about distance. He's talking about distance traveled, something the mathematicians never figured out. You know, there's a difference between distance and distance traveled. And what the mathematicians don't use ever is distance. They have no use for distance. They have no use for dimensions or distance. Dimensions are the mathematical brains. They're talking about number lines, not about dimensions. They're talking about numbers. What is a dimension according to the bean brains of mathematics? It's a number of numbers. That's got nothing to do with length, width, or height. Okay? So length, width, and height is what we have in physics. And in the religion of mathematics, what they have are number lines. And they call those dimensions, vectors, coordinates. They use all these names. They're number lines. They have nothing to do with the dimensions of physics. But they later on, they extrapolate their language into physics. They step over the line. They say, well, we call them dimension over here, so we're going to call them dimension over here as well. And so they talk about the dimension of time. Time is a number line. They call it a dimension. You're going to go through this time dimension faster than if you go through the space dimension. Okay, that's how they trick you with their language. It's all semantics on their side because they never define these terms in physical terms, in scientific terms. That's the issue. Okay, so what's the issue? The issue is what kind of, here you have what I showed the other day, which is you have the space time sheet, the, what is it, the canvas, the fishnet, and you have the photon going the long way, and you cut across through the wormhole, you know, to, you know, for example, the Andromeda galaxy. So while the photon takes all this time to go around, you go straight. And you say, does this make sense? The photon's going through space, you're going through time. Well, why doesn't the photon go through time and beat you to it, you know? Well, they say it's a shortcut. Essentially, that's what they're saying. And the question is, in what way, what kind of medium is this so-called time that you can go through it, and how viscous is it? I mean, is it less viscous than space? I mean, space is nothing. There's nothing there. So you can't have anything less viscous than space. And these people are saying that there's something less viscous called time, and it's so light, so less dense than space, that you're allowed to travel much faster than through space. That's what they're coming up with. That's essentially what they're saying with this brachydachrome issue. Okay, and here's another vision of that. Okay, you stare from our galaxy. Let's take that to be the one on the right, lower right, to the Andromeda galaxy, the one on the upper left, and you can see it directly. You know, without that wormhole there, you can see it straight. Directly. Light takes that straight path because we see it through the telescope every day. And these people are switching these two things around. They're saying, look, light, when you're looking at the Andromeda, you're really looking through this curve that takes a long time to get to Andromeda. Whereas if you took the wormhole shortcut through the time dimension, not through the space dimension, the 3D space dimensions, right? You're going to go through the time dimension, which is less dense somehow. And it takes you there much faster than the normal path of light. So they switched these things around. That's what they're telling you, essentially, if you can picture this at all. And yeah, they come up with all these tricks like brachydachrome and nonsense that mathematicians invent to try to fool you. And they believe in it. A lot of people really believe in this garbage. They have, my God, sand up there, or maybe nothing between their two ears, empty space, or less dense time. I don't know what they have up there. This is baby stuff. This is any kid should be able to figure it out intuitively. You don't need math for this. Another issue, another question, knowing nothing about Heisenberg's uncertainty principle. Adding insult to injury, make fun of quantum tunneling. Yeah. We can't take this seriously. I mean, what are you going to do? And here you see Heisey, Werner Heisey, I call him, okay? And this is what he said. Essentially, this is Heisenberg's uncertainty principle for what he gained his Nobel Prize. He says, when the ball moves, it doesn't stand still. And when the ball stands still, it doesn't move. Great. Jesus. I mean, he must have busted his brain to figure this one out. He says that the more you know about momentum, the less you know about position. And the more you know about position, the less you know about momentum. Are we supposed to take this guy seriously? And what are they referring to, these bean brains from quantum mechanics? This is what they're referring to. When they talk about position, they're actually referring to the photon or to the electron. They're talking about a particle, a discrete particle. When they talk about momentum, they're actually talking about the wave. That's when they slightly introduce the wave in their discussion, because the wave is spread out. Usually you got to think of it as a spherical wave. So the position turns into a spherical wave, and the spherical wave turns into a position. And the more you know about the momentum, about the wave, right, and how it's spreading out, the less you know about its position. And the more you know about the position, the less you know about the wave spreading out. So this is their notion. This is what they have in the back of their minds. Okay. So yeah, it's all nonsense, all of it. 150% of quantum mechanics physical interpretations are nonsense. In fact, don't take my word for it. Niels Bohr already said, look, if you think you can imagine anything related to quantum mechanics, you're an idiot. He told Feynman that he was an idiot when Feynman was young. Later, Feynman became a god, but Niels Bohr had very little respect for him. So did Dirac. You know, these were the old folks, the previous guard, the old guard, and they were laughing at people like Feynman. And Feynman later became, a hero. But essentially, yeah, they said, if you think that you can imagine anything about quantum mechanics, you are an idiot. That means you didn't understand squat. Okay, so let's make sure you understand that. Don't ever say that you understand quantum mechanics, because you're going to be in trouble immediately. And not with me. I'm talking about the quantum, the mechanics. Okay, they're going to laugh at you. Okay, nobody can imagine quantum mechanics. They cannot put it in words. They cannot illustrate it. Okay, another fellow says, the precession of the perihelion of Mercury has been calculated by Einstein, with Einstein fudging the whole stuff because he knew the result measured by Leverrier and others by the turn of the 19th century in advance. That's pretty much true. Actually, he used Newton's equation for the biggest part of the calculation and added some of his terms from GR to cover the gap. I call that fudging the results. His GR theory should have predicted the whole thing without Newton equation. The whole thing is just not coherent in itself and highly suspicious. Let me give you a couple more a little more fuel to the fire. Let me throw a little bit of gasoline into what you just said, which is pretty much on the money in many ways. Okay, keep this in mind as well. Okay, and here you have it. General relativity uses little c as a constant, and there is no reason to use little c as a constant, because little c is going through a curve. You know, when Eddington in 1919 allegedly proved that the photon curves around the sun, the warp space that the sun creates by, bending the canvas, the fishnet. Well, if the photon is curving around the sun, okay, then the photon is not traveling in a straight line, and it's not traveling as a little c, which is 300,000 kilometers per second. That means you can't put 300,000 kilometers per second in the equation. And yet, these people just put the little c in there no matter what. They just use c at all times. And they can't if space is warped and the photon has to slide along a curve. Okay, so you have angular momentum there. And angular momentum slows the photon down. Maybe the photon's traveling at 250 or maybe 200,000 kilometers per second. So you can't use 300 all the time. And see, they could continue using in their equation 300,000. The other issue you should keep in mind is GR uses the gravitational constant G, which is determined by the Cavendish torsion balance experiment. Okay, and that's a micro scenario. We do that, in the laboratory. We use that in here on Earth. And GR only works out there in the cosmic scenario. GR is only, this bent or warped space is macro stuff. That's why you can't use general relativity to explain, why this pencil fell to the floor. GR is only out there, is the big picture, is only cosmic stuff. Yeah, GR tries to describe, not explain, it can't explain anything, but it tries to describe the orbit of Mercury, which is what this fellow talked about just now. And they use the gravitational constant G, which is determined through a micro scenario. You can say Cavendish's experiment deals with quantum mechanics, or classical, if anything, but it should be dealt with since quantum replaced classical mechanics. Well, explain it with quantum mechanics, please. Show me how the particles force the torsion of the balance. Okay, that's what you got to show with quantum mechanics. Show me the process, the mechanical process. And of course, they'll tell you they can't understand it. But you can't use the letter G, that value. You can't use that constant there's no justification. They just say use it out there and that's it. Why? You determined it down here, and general relativity is for macro stuff. So you got to keep those issues in mind as well. Okay, another comment, moving on here, a couple more and then we're through. Here's another comment by someone. It says, time travels. Of course it is no sense. His English is not too good, but we'll try to read it. It's human imagination because we have memory, and time is comparison of two motions, and the entity that compares have memory. Yeah, essentially you're comparing two motions, that's time, and so it's all subjective. It's here, okay? Once humans die, there's no more time, or all animals die, there's no more time. Time is an animal issue. We created time. Okay, we can imagine, think about time. The universe, before we were born, there was no time out there. In other words, before that, it was all clockwork, just motion. Time came into existence, you could say, to use that word, came into being when we were born. That's when time began. And I don't even think that soon. It took some evolution for us to figure out time. Okay, we can imagine going to the past and the future, change the events of the past and change the event of the future. If we assume that it is possible, this means that the future's already happened. So it is already past. Yeah, that's what I covered a minute ago. Essentially, if you go to the future, if you go to the block universe, you're going to the past. In fact, keep this in mind as well. Take note of the time when you left and the calendar. Okay, you look at the calendar and say, what day did I leave? I left on the 3rd of May, a Friday, and I left at 12 noon. Whatever comes after that is known as the future. Okay, assuming you traveled from that point on, and you traveled not where but when. Okay, you traveled to the future from that point onwards. Your clock is ticking forward. Your watch doesn't click backwards as you go through time. Okay, so when you travel to see Napoleon, you're also traveling to the future. Okay, because you're saying, well, I traveled to the year, 1815, Waterloo, right? Yeah, but you traveled from this point. Your watch is going forward. Even your atomic clock is moving forward. It's counting seconds forward, right? How much time since you left. So when you go to see Napoleon, you're going to the future. That's the when you're going to. You're not going to the past. You say, well, I saw Napoleon, yeah, but he must have been in the future because it's, according to your watch, it's from this point onwards. And time after the present is known as the future. You see the problem? So whenever you travel to the past, you're also traveling to the future because it's time after the present moment, which is when you left. You're here and now. Okay, so keep that in mind as well. Okay, final comment. Let's see if we can get this one out. And here it is. The word rational means it must be observable and describe what it really does. So what's rational science? Well, no, that's not what the word rational means. So let's define the word rational for this individual. So we know what the word rational, we had to define this word. This was another key word that we had to define because people say, oh, I'm rational. I believe a particle can be at two places at once. And I believe that, this particle can affect that one from a distance without touching it. And, you know, the guy says he's rational because he saw it in the lab and proved it. No, this is what rational is. This is the criteria that we use. These are different things, 5 of them here. Treating concepts as objects, reification, concretization. That's irrational. Okay, so if you move a concept, you move energy, you transfer energy, you move a mass, you stretch the field or whatever, you're reifying. You dilate time, you're reifying. And that's prohibited by science, that's prohibited by physics, and so you can't treat a concept as an object. Same goes for plasma, electricity, vortex. You can't use those as objects, those are concepts. Using inconsistent definitions or undefined words. Okay, you got to use those words. First you got to define, then you got to use it consistently, rationally, scientifically. And a theory doesn't follow from the assumptions. Okay, describing and claiming to have explained, and the mechanism proposed doesn't work or cannot even be imagined. Okay, there we have God trying to figure out how to square the circle. Okay, so those are the definitions of rational. And so, yeah, and then science is explaining. So rational explanations, that's what rational science is all about. And with that, I'll see you, what is it, Wednesday. We'll see you then. Bye-bye.